All right, the final section of chapter 1 is working with three-dimensional figures. We're going to be finding the volume and the surface area of these. We already talked about how to find the area and perimeter of two-dimensional figures, and now we'll work at three. So when we're talking about the difference between a two-dimensional and a three-dimensional figure, polygons are two-dimensional, so they're flat on a piece of paper, where three-dimensional, we're talking about polyhedrons. And so here I have three examples of a polyhedron that are drawn out, and they look 3D. It looks like it's popping out of the page at you. And the reason that they are 3D is because they have more than just one plane that creates them. Now, of all three of these, they have what we call edges, vertices, and faces. So the edges seems fairly kind of simple to understand here. Those are all of the edges. So if I think about this box right here and I count up all of the edges, that's how many edges this polyhedron has. And so this one here has 12 edges. And the vertices is where the points meet. All of these here, those would be our vertices. And so we end up with 8 vertices. And the number of faces is how many planes you have. So when I look at the left side here, there's 1. I got the right side, so that's 2. You get the front, the back, and then you got the top and the bottom. So we have a total here of 6 faces, 6 planes that are being used to create this rectangular polyhedron. The next one here, we've got, as far as edges go, I've got 1, 2, 3, 4, 5, 6, 7, 8, and 9 edges. The number of vertices that are here, 1, 2, 3, 4, 5, 6. And the number of faces, I've got a triangle in the front and the back, so it's 2. And then I have 3 rectangles to make this end up having 5 faces. The next one here, we have a type of a pyramid. And when I look at all the edges, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 edges. Vertices 1, 2, 3, 4, 5, and 6. So we have 6 vertices. Number of faces, I have the bottom, which is 1, and then I have 5 sides around that. So that ends up giving us a total of 6 faces. So just kind of looking those over. The reason we're talking about that is because it's going to help determine whether we have a prism or a pyramid. A prism is a polyhedron with 2 parallel congruent faces. So when I look at these here, here's a couple examples. I have a triangular prism. Reason that's called a triangular prism is because it has 2 triangles that are parallel to each other. They're never going to touch each other. They're parallel. So that's kind of like the back and the front or the top or the bottom. Here, rectangular prism, I have a rectangular bottom and I have a rectangular top. Those sides are parallel to each other. Pentagonal prism, I have 2 pentagons that are going to be parallel to each other that are never going to touch. It's the rectangles that are all around this then that allow for those 2 the triangles, the pentagon, the rectangular to not touch. Now a pyramid has a base, and then all the faces except for one intersect at one vertex. So they all go up to that one point. So here I have a base of a triangle, and then all of the sides are going up to that one point. Here I have a base of a rectangle, and all of the sides are going up to that one point, making it be a pyramid. Now, the one thing that probably gets people the most confused is the difference between a triangular prism and a rectangular, oops, this is prism, sorry, this is supposed to be pyramid. And that's not allowing me to write. Okay, sorry about that. So looking at a rectangular pyramid versus a triangular prism, those two get people messed up all the time. So as we start looking at volume and surface area, the one thing that we need to know how to find is we have to know how to find the base of a prism or a pyramid. And so here I have 2 examples of 2 prisms. And again, the reason they're prisms is because they have the 2 faces that are parallel to each other. And now when I'm talking about the base, I'm talking about I need to pick one side, but the opposite side is the exact same thing. So if I look here, if I look at this rectangle, I know that the opposite side of it here is identical to it. So the base, okay, now I can say that my base, I can use that as my base. When I look at the next one, people all the time want to say, oh, there's my base, because that's the bottom of it. That's not the case in this problem. It's put on its side, and the base is actually going to be this triangle. So we've got to be very careful about what the base of a prism is. It's a little bit easier to find the base of a pyramid because it's the side that's not going all to the same point. Here you have a triangle for your base. Here you have a rectangle. And the reason that we're using these is because our formulas that we do, we have just one general formula that's used for surface area for a pyramid, surface area for a prism. Doesn't matter what the base is, what shape it is, and we can always use this formula. Now, if you look at a couple other three-dimensional figures that are not polyhedrons, we're talking about a cylinder, a cone, and a sphere, we can still find the volume and the surface area of these objects, and we will be doing so today. But just realize that they are not considered polyhedrons. So going on to finding volume and surface area. The way that I like to think about this is volume is the measure of the amount of space that the solid encloses. So if you think about a box, like what all can you stuff into that box, that's the volume. When you talk about surface area, we're talking about wrapping up a gift. If you wrap something up, how much wrapping paper do you need? And that's your surface area. When we're talking about volume, we're always using units cubed. When we talk about surface area, we're going to be using units squared. With the word area, we keep it squared. So the next thing here is the formulas that are going to be used. Now you may need to pause this video so that you can write all of these down, and that's fine. But what I want you to realize here is that these formulas work for any prism, any pyramid, any cylinder, any cone. So this first one right here, this is for a prism. The next one's for a pyramid. And then you have a cylinder. And then you have a cone. We're not doing sphere and stuff at this point, but we're going to use these four. So a prism, to find the volume, it's equal to capital B times H. Now capital B, what that's doing here is it says that's the area of the base. Now you have to think to yourself, okay, what's the base? The base is one of the sides that's parallel to the other. So I could be a rectangle, it could be a triangle. So then I have to think about, okay, well, what's the area of a rectangle? Length times width. If I was to go back here and use my triangular prism, I would have to use the formula for area of a triangle, which is 1/2 base times height. So I would have to know what the height of that triangle is along with the base to be able to find the area of the base. So be careful, capital B is the area of the base. Multiplying it by its height, so how tall your prism is. So we've got the area of the base and the height. Volume of a pyramid, we're taking 1/3 the area of the base once again times the height. So when we talk about the area of the base, I'm looking, in this case here, I'd have a rectangle, so I could use length times width. The height that you're using is getting dropped down right from the point of where everything intersects and right down to the middle of that rectangle or triangle, whatever shape it may be. Cylinder is pi 3.14 times the radius squared times the height. Radius goes from the center of your circle to the outside, and then the height is how tall your cylinder is. Cone, we're going to use the radius once again, and then we're going to talk about the height, which is going to go right from the point here, drop that down to the center of your circle, and there's your height. So there's our formulas being used for volume. Again, your units that we're using are units cubed. If you need to, stop the video, write down the problems, because now I'm going to go on to surface area. Surface area, units squared. Here, we're still going to use capital B, which is the area of the base, but we're going to add in a few new things. So if I look at a prism, which right here I have a rectangular prism, I need to do two things. First thing, I'm taking capital P. Capital P is the perimeter of the base. That means that I need to calculate what the perimeter of this rectangle is. Now again, you might have to, if you're working with a triangular prism, I might have to find the perimeter of the triangle. Depends on what type of shape you have for your base. So finding the perimeter of that triangle times the height, which is how tall our prism is, plus 2 times the area of the base. So again, the area of the base is the inside, which I have shaded in yellow. To find your working with a pyramid, you're going to take 1/2 capital P. So once again, you're talking about the perimeter, finding the distance around your base. And the next part here is this script letter of L. What that's talking about here is it's talking about the slanted height. And the slanted height is what goes along the triangle here of one of the sides up to that point, so resting along that. Not to be careful, because that's not what the height is. The height gets dropped down right from the center. That's the actual height. The slanted height goes off to the side. And with this one here, you are also working with adding on the area of the base then. So that's what we have here. Cylinder, not as complicated. We once again need to know where our radius is, and really you just need to know what the height of your cylinder is. And then you have your cone, which you need to know what the radius is, and you have to know your slanted height, which your slanted height is going to be along the edge. So just be careful here that it's not the height. Okay, the height would go down from the center to the center of your circle. The slanted height is going to go along the edge. So there's our formulas. Now, I'm not going over any examples quite yet on this video, but what I want you to try and do, come to class tomorrow, and I want you to try and see, can you use these formulas of surface area and volume that I just gave you, and can you now find the volume and the surface area of these two three-dimensional figures that I'm giving you. Everything's there that you need. Try and see if you can find the volume and the surface area of these two problems, and have that bring that with you to class. Come up with an answer, okay? Do your best. Show your work along with it. So I don't want to just see an answer. I want to see what you're adding, what you're multiplying together to get that. If I had to find the area of a rectangle and I had to take 5 times 2, even though I know the answer is 10, I'm going to say 5 times 2 is 10. Show your work. Okay, you need to have this in class to be able to continue with the in-class assignment. If you have questions, write them down, and be sure you come talk to me, and I'll see you tomorrow.